All right, let's talk about Streamlit. If you're a Python developer and you need to get a web app up and running fast without getting tangled up in a bunch of front-end code, then this is the tool you need to know about.
In this explainer, we're going to dig into how Streamlit actually works under the hood. We'll cover its capabilities and the most critical commands. Our goal is to give you a solid, technical understanding of its core mechanics, because once you master these, you can build much more powerful and efficient applications.
We've broken this down into 4 parts. We'll start with the execution model. That's the absolute foundation. Then we'll get into creating apps with widgets. After that, we'll tackle how to manage interactivity and state, and we'll wrap up with optimizing performance through caching.
Okay, let's start with the single most important concept. Honestly, if you understand this one thing, you understand Streamlit.
At its heart, you can think of Streamlit as a translator. It takes your standard Python data script and, almost like magic, turns it into an interactive web application. This lets you stay focused entirely on the data and logic without ever touching HTML, CSS, or JavaScript.
This right here is the absolute core of how Streamlit works, the rerun loop. Every single time a user interacts with your app, clicks a button, moves a slider, anything, Streamlit reruns your entire script from top to bottom. This simple, reactive loop is what makes development so incredibly fast, but it also creates the 2 main challenges we're here to solve.
And here they are, the 2 big consequences of that rerun model. First, performance. If you've got slow functions, they're going to get re-executed on every single interaction, which can really bog down your app. Second, state persistence. Since all your variables are recreated on each rerun, your app essentially has no memory. The rest of this explainer is all about solving these 2 problems.
So, with that execution model firmly in mind, let's look at the tools Streamlit gives us to actually build the user interface itself, and that means talking about widgets.
These are your foundational commands for just showing stuff on the screen. You've got titles, headers, and text. st.write is the real workhorse here. It's incredibly versatile and can handle everything from text to data frames to plots. And then you have specialized commands like st.dataframe and st.linechart that are optimized for presenting data.
The real magic, though, comes from the interactive widgets. These are the elements that your users will actually click, check, and slide. And any change to one of these is what triggers that top-to-bottom script rerun we just talked about.
Now this is the crucial point, how you capture user input. When you call a widget function like st.selectBox, it returns its current value. You then assign that value to a regular Python variable. So in this case, the selection variable will simply hold the string A, B, or C, making the user's choice immediately available for you to use in your script's logic.
Okay, we've seen how to build a UI. Now let's tackle that first big challenge we identified, losing your application's state between reruns.
Think about this for a second. Imagine you have a variable count set to 0. A user clicks a button and you increment it to 1. Simple enough. But what happens when the user clicks that same button a second time? What's the value of count now? The answer is it goes back to 1. Because the entire script reruns, that count variable gets reinitialized back to 0 every single time, and then it's incremented to 1. The fact that it was 1 a moment ago is completely forgotten. This is the problem of lost state. And here is Streamlit's elegant solution, s.sessionState. You can think of it as a special dictionary that actually survives the rerun loop. Anything you store in it will still be there the next time the script runs, at least for that specific user session. So to fix our counter, we just need to store its value inside st.sessionState. We initialize it if it doesn't exist, and we increment it on each click. Now the state persists and our counter works exactly as you would expect. Problem 1 solved.
Now for that second major challenge, performance. How do we stop our app from grinding to a halt when it has to rerun a slow, computationally expensive function over and over again?
The solution is caching. Streamlit can intelligently store the output of a function. The next time the script runs and calls that same function with the same inputs, Streamlit just pulls the result from its memory, the cache, instead of running the function all over again. Streamlit provides 2 distinct tools for this, and choosing the right one is critical. At st.cachedata is your go-to for most things, loading data, processing arrays, you name it. It returns a safe copy of the data. In contrast, at st.cacheResource is for heavy shared objects like a machine learning model or a database connection. It returns a direct reference to the object in memory, so you have to be careful not to modify it.
This table shows the practical difference really clearly. Reading and transforming data frames, that's at state.cachedata.
Loading a large ML model or establishing a persistent database connection, that's a job for @state.cache resource. This is a great little cheat sheet for your projects.
Implementing it is as simple as adding a one-line decorator right above your function definition. With @st.cachedata added here, the load large data frame function will now only execute one time. Every subsequent rerun will instantly retrieve the data frame from the cache.
This quote from the documentation sums it up perfectly. Caching is the key to transforming a potentially slow Streamlit app into a highly responsive one, simply by eliminating redundant work.
So let's recap the crucial points. Streamlit's magic comes from its simple, top-to-bottom rerun model. That very same model creates two core challenges: state persistence and performance. And Streamlit gives us two precise tools to solve them: st.sessionState for state and the caching decorators for performance.
Understanding these core mechanics unlocks the true potential of the library. It moves you from just building a simple app to architecting a fast, robust, and stateful experience. So the only question left is, what are you going to build with it?